and thank you for tuning in. Today, I'll be talking through how reverse ETL plays a role in why data quality has gained so much attention recently. So, more specifically, reverse ETL has ingrained itself in the modern data stack, allowing many people, non-technical people specifically, to send data directly to the tools that they use day to day. But with power, of course, comes great responsibility, or so they say. This ease of use exposes bugs and untested systems. Adding in tests and putting gates in place ensures reverse ETL can truly be leveraged to its highest potential. But before I kind of talk through why data quality tests are so important, a little background on me. I'm a data engineer full-time and a technical writer. I work at Perpay, which is based in Philly, and shameless plug, we are hiring for a variety of data and non-data roles. Additionally, you may have seen some of my articles floating around trying to convince you of certain concepts floating around as buzzwords in the data world, like data lake or reverse ETL, data quality, so on and so forth. I guess I'll continue to do that. So let's dive in. I mentioned the modern data stack. What makes it modern is a question that many ask. So yeah, tools like Fivetran, Census, DBT, Snowflake, you've probably heard at least of one of them, if not all of them. They've emerged and become popular in recent years. So of course, by definition, that is, so to say, modern. But more than that, the modern data stack, quote unquote, is an evolution of data tooling that's truly allowed non-technical people to be more effective and easily make decisions based on data. But of course, when information becomes highly available, it also means it's highly visible. High visibility means accuracy and freshness become extremely important. Walking through this graphic here from Census's website, stakeholders use apps. For instance, your sales team might use Salesforce as a CRM, your marketing team likely runs ads on Facebook or Google. So to get that information into your data lake or warehouse, Fivetran, an ETL tool, will do that for you very easily. Once that data is centralized, it sits parallel with your first-party data. And DBT in this space has truly changed the game when it comes to scaling queries and data models using SQL. So joining first-party data to sales or marketing data has never been easier than it is today. Now, we're in a state of total centralization. The warehouse is a source of truth, right? That's a great place to be. But the sales team still relies on Salesforce, and that's what they use day to day. The marketing team still uses Facebook ads daily and wants to run more personalized ads. So what now? With tools like Census, or there's HighTouch, Airbyte, Grouperoo, so many to choose from in this space, but all of them are reverse ETL tools. If you consider ETL, like Fivetran, is taking data from apps and syncing it to a warehouse, then reverse ETL is taking warehouse data and syncing it back to third-party tools. So consider an e-commerce company with transformations resulting in clean first-party product catalogs that can be sent to Facebook ads, building tailored ads for this specific product catalog. Today, using modern tools, as we just discussed, this flow can be built to run on a schedule, thanks to Airflow, or there are other workflow orchestrators out there like Dagster or Prefect, with ETLs, reverse ETLs, data models set up by single analytics engineers. So all of this, again, made easier than ever before. So let's run through this. Consider your average product catalog with sponsored ads built on top of it. The product catalog comes from the database backing the online marketplace, queried to build a clean and formatted catalog. Items go in and out of stock, but when one is out of stock, ads should not be built on top of it. Super logical, right? So if you can't sell an item, why would you want to advertise for it? say with the new release of the backend of the online marketplace where this data originally comes from, the underlying data changes. No sweat, right? This is pretty straightforward. So when the in stock flag is 1 as opposed to 0, the item is in stock. Again, pretty logical. But if you look a little closer, that's really not what was coded. Changes happen quickly, especially in a startup. You need to move fast. It was almost too obvious and missed in a pull request review. So by accidentally flipping the condition, the product catalog is actually only showing out of stock items. This is a product catalog, remember, with ads built on top of it, and those ads are paid ads. So where does that leave us? So in this situation, depending on what alerting might be set in place, this issue could go unnoticed for minutes, for hours, for days, and hopefully not weeks, but again, going unnoticed. While the issue exists, that means marketing dollars are spent leading customers to items that either show out of stock on the website or to links that simply don't exist, aren't functional, and basically items they just can't buy. Worst case scenario, the links, again, aren't even active links, so you're not even leading customers to your site. And there's always the question of how a particular metric impacts KPIs. So in this case, I would imagine these new product catalog ads don't convert very well, right? If they're not leading customers to products they can buy or not even leading customers to your site at all. With low conversion rates, if they're not 0, total revenue from paid marketing takes a deep nosedive. And for many businesses, so revenue from paid ads is a large percentage of the business, as large as potentially 30, 40, 50% even of all customers. So could you imagine if 50% of your revenue was supposed to come from a marketing source where you're showing only out of stock items? That's not great, not a great situation to be in. So what can be done? Over the summer, if anyone remembers, many of us received this email. So thanks to an intern at HBO Max, we know HBO Engineering tests their product. Although, of course, this test was a little too customer facing since we all got it, and here I am talking about it, but that's not the point that I'm trying to kind of hone in here. If software engineers test their product, why wouldn't analytics teams do exactly the same thing? Analytics teams output a data product, a data platform that powers data-driven decision-making across sales, marketing, BI tools. If the output the analytics team creates drives decisions that impact a business in a significant way, influencing those KPIs that I mentioned earlier, then I would argue the data platform is a production product. So let's think through this word production. It's a name given to a system that is supposed to be highly accurate, highly available, and very, very reliable. In the consumer app world, it's anything that's end user facing. In B2B, it's anything that's customer facing. More than that, it's anything that impacts the customer either directly or indirectly. If analytics teams inform product teams on which products are effective, which products should be rolled back, that indirectly, or some would say even directly, affects the end user. So what do availability, accuracy, and governance mean in the data world? First and foremost, key fields that drive this decision-making should be tested, both to make sure that they are calculated correctly, as well as testing they just logically make sense in the context of the business. Second, processes that expose information to decision makers or directly to the consumer, like the Facebook ads example I walked through, should be gated. What I mean here is run tests, and if data doesn't meet certain expectations of the way that the world should look, just don't run these processes. Don't send that data through. Stale data is better than incorrect data 99% of the time. I would almost argue 100% of the time. And lastly, testing is a proactive measure to take. So during development of a new feature, or in the data world, say a new query, a new DAG, a new process, the existence of tests allows the person developing to check if their change makes sense with all existing assumptions. This is extremely powerful as it further removes human error and bias in just forgetting to check particular parts of the system. So testing sounds good, right? But let's dive in deeper into what we actually want to test. I categorize data tests, again, for improving data quality into two categories. The first is logic tests, and the second is business metrics. When testing data quality, we want to make sure at a higher level the data just simply makes sense. Data logic and formatting needs need to make sense, meaning, in this sense, a column showing the price of a product likely needs to be an integer column. Or a particular table needs to contain a certain list of columns in a certain order. These types of checks will help ensure that downstream processes don't fail. For instance, changing a particular column name in the warehouse, storing the product catalog, would indicate a change is needed to the reverse-ETL process that uses that column to map to a third-party tool. If the reverse-ETL process isn't changed in parallel, a downstream process will fail. Now, diving into business metrics. So business metric tests are unique to every organization, but the premise is the same. Test your data in the context of a human employee at your company. What questions are you going to be asking, and what situations do you never expect to be present in the data? For instance, a column indicating stock of a product must be in stock or out of stock. If the name of the product is accidentally written to that column, then this type of test would fail, and rightfully so, because in this case, even though you didn't do just a switch on its head, you also wouldn't be showing any products in your ads, as nothing would be quote unquote in stock. Additionally, this would be a great place to ensure a percent column is stored as a whole number if that's the intent, as opposed to a decimal. So if your marketing team filters on a percent column to only target users that meet a particular threshold for just more targeted marketing, that threshold would be very different if it runs from 0 to 1 or 0 to 100. Writing this type of testing framework from scratch would be a huge amount of work, and I'm absolutely not expecting anyone listening here to do that. But luckily, there are tools out there to make data quality testing a whole lot easier. One of those tools is called Great Expectations, an open source library maintained by the team at Superconductive. There are plenty of open source alternatives, as well as closed source tools like Datafold and Big Eye that are extremely feature rich, but I'll just dive into Great Expectations just to do a proof of concept here. So a key to these types of libraries, all of the ones that I mentioned and all of the ones that you see here on the slides, is the ability to quickly build both logic and business metrics tests. So in short, Great Expectations allows you to code what you expect of your data in Python. These expectations are, these expectations of data are then validated against anything that you change on demand. So likely each time the pipeline is run before the data is stored as production data. Lastly, all of these expectations and validations are documented. So in particular, if a validation fails, it's very easy to see when and why it failed. In the example here, the function on the left is saying a field called passenger count is expected to be between 1 and 6. But the documentation on the right is indicating that a validation failed because the field was actually 0. Data quality tools don't exist to just replace data engineers, but exist so data engineers don't have to write boilerplate SQL queries over and over and over and over again. These tools make testing data about what tests should be unique to the business and what tests should exist, and less about how to scale a testing framework. So about this testing framework, so now if we have tests, where they actually fit into the bigger picture of the data stack. Tests serve as a gateway. So a gateway from tables in the data warehouse to any place anyone would actually use data, whether it be a BI tool, a sales tool, a marketing tool, depending on the needs of the business, or, anywhere else. So let's walk through this step by step. Many workflow orchestrators, like Airflow, are built around the concept of a DAG, a graph of nodes with non-cyclical dependencies. So consider the example we've been walking through. A DAG would consist of a DBT operator refreshing DBT views or tables, and this is really what generates those clean data models in the data warehouse. On top of those models, we have an operator running data quality checks, for instance, Great Expectations, like we just walked through. And here is where we check tables for column order, column names, column values, the business and logic checks I just talked about a minute ago. So now for the most important part. If those tests do not pass, we do not send data anywhere as it's not considered production ready. That's why we have those tests. So the BI tool isn't updated, third-party tools aren't updated through Census or any reverse ETL process. Instead, we can trigger an alert to the team or whoever is responsible through Slack or email to investigate. If these tests are critical, then the team should and would be ready to investigate fairly immediately. So an important note here, the tests that gate these downstream tasks when they fail should actually be critical. We're not checking for a change in distribution that might indicate a shift in the business. If that's the case, that's just the way it is. We might want to alert on it, but we still would want to send data through. We're truly looking for inaccuracies in data where we do not want to send it through because, again, it wouldn't be right. So having a testing layer enables so much more. Specifically, the ability to be confident in a dry run in a separate non-production environment. First, this isn't an engineering-only concept. Not just in professional theater, but high school theater groups do a full dress rehearsal before the live show without an audience. The stakes are much, much lower, or even non-existent, to allow a space to groom out any of those minor or major issues, whether it be forgetting lines or something about the costumes. So similarly in analytics, why wait until the live show? Why wait until production to groom out these issues? We can be much more proactive than that by testing any changes in a completely separate place. So what does this actually look like? Consider a completely cloned production data platform with either a separate database or an entirely separate warehouse. Additionally, imagine within that data platform, there's an entirely separate instance of Airflow to schedule jobs. This separate platform can run any code we want. So if the production platform is running the production GitHub branch being master, then say the staging platform runs the staging branch. If a change is being proposed, then that feature branch can be merged into staging first and not into master. Then those exact same data quality checks will run after any changes to data models. If they pass, fantastic. Then you can be more confident in merging your branch, knowing that nothing critical changed. If, of course, your tests are thorough. If it fails, you can get alerted just the same, fix the issue, and try again. Here, the most important thing is that the stakes aren't high, or there aren't even any stakes. You can simply just try again. One note here, if the proposed change renames a column, or something similar, you'll have to change your tests. And if tests change, so do downstream processes, like mappings to your third-party tools in your reverse ETL. However, if no tests change, that's when you can be sure downstream processes should run perfectly fine. I know this is more infrastructure to manage that comes at a cost. However, let's consider the cost of revenue dropping due to marketing out-of-stock items on accident. Lack of thorough testing also comes at a cost. In this case, the cost gives you peace of mind when you have this ability to do dry runs, and to me, that just makes me sleep much better. Wrapping up, data platforms are production systems themselves, or at least part of production systems. So they should be treated as such with comprehensive testing for data quality. Building a testing layer as a gateway to downstream, highly visible production tools allows data teams to make changes confidently. I mean, making changes without risking the availability or accuracy of the data flowing through the system. Using testing as a gateway instills confidence in the analytics team and in the analytics product, confidence that, if lost, is very hard to regain. Thank you so much for your time, and I hope you enjoyed. Of course, happy to chat further. Thanks.